in the e-text, or on Wikipedia, or probably if you just type the question into Google, you'll find a formula for the derivative of the arcsine function. That's all well and good. You could memorize that. But then you might ask, well, what's the derivative of the arccosine function? What's the derivative of the arctangent function? You could memorize all of those. But what I want to equip you with is an understanding of why those formulas are as they are, and I hope that will set you up in case you ever forget them, you could figure them out. I think the biggest stumbling block in this question is simply the unfamiliarity of the arcsine function. In other words, if we don't understand what arcsine t means, we won't be able to compute the derivative. A common trick in understanding mathematics is to give things names. So let's call arcsine t theta. I've picked the letter theta for a reason. If you think about it for a moment, what sine does is to send an angle to a ratio. Arcsine, being the inverse of sine, should go the other way. That is, it should send a ratio to an angle. So the output of the arcsine function should be some kind of angle. I've picked theta to remind myself of that. What specifically does theta equals arcsine t mean? It just means that sine of theta is t. And now we're going to do some trigonometry. What does it mean for sine of theta to be t? Well, that's a statement about an angle in a right triangle. If I set the hypotenuse to 1, then the opposite leg has length sine theta. Now I'm going to take this equation, sine of theta equals t, and I am going to differentiate with respect to t, the variable I'm interested in. On the one hand, the derivative of t with respect to t is just 1. On the other hand, if I differentiate sine, I should get cosine. But I need to remember that theta is a function of t, so I need to apply the chain rule. If I put that together, I can solve for d theta dt. Why do I want to solve for d theta dt? Well, remember, theta is nothing more than arcsine t. So it looks like I have my answer. I should answer 1 over cosine theta. What's the problem with that? If I ask you a question in French and you answer me in German, that kind of makes you a jerk. That's a little bit like what we've done here. The question was phrased in terms of t's and we've answered in the language of thetas. So what we need to do is to go back from thetas back to t. How do we do it? Let's look at this triangle again. Notice that the adjacent leg has length cosine theta, which is what we care about. Can we express that as a function of t? Of course we can, using the Pythagorean theorem. So there we go. We now have a formula for the derivative of the arcsine function. To really lock that in, let's do the same thing for the arctangent function. And we'll use exactly the same trick. Except now, when we populate our triangle, we have to remember that tangent is opposite over adjacent, which means we need to label our triangle this way. Again, we differentiate with respect to y. And on the right-hand side, we get 1. On the left-hand side, we use the chain rule. So we obtain secant squared theta times d theta dy is 1. In other words, d theta dy is cosine squared theta. We replace theta by arctangent y, and we get the answer. The derivative of arctangent y is cosine squared theta, except again, we need to convert back into statements about y. And we remember that the cosine of an angle is the adjacent leg divided by the hypotenuse. With Pythagoras' help, we figure out the hypotenuse and use that to express cosine, which we can then plug into our formula. At the end of the day, we obtain that the derivative of arctangent is 1 over 1 plus our input squared. Now, on your own, you can compute the derivatives of the other arc functions, but I want to point out this is not just about trigonometry. The same idea will work to help us compute one other derivative that we care about. The first step is to name log x with another variable, call it y. What does the equation y equals log x mean? Just that e to the y equals x. Now we differentiate. As usual, the right-hand side is 1. And the left-hand side we use the chain rule for. We solve for dy dx, because y is nothing more than log x. And now we have a formula for the derivative of log x. Except that that derivative is expressed in terms of y. We need to convert back into x's. In fact, we had already converted from y's to x's. There we go. We have found a formula for the derivative of the natural log function.